These notes will help you fill out the top flap of section number 5 of your Unit 3 Quadratic Functions flipbook. The essential question for this video is, how can I use a graph of a parabola with a vertex at the origin to find the function? So before class, we've been taking a function and then plotting points, putting them in a table, plotting some points, and drawing the parabola. The question we're being asked now is, what if all I have is a graph of a parabola? Can I figure out what the function is, or what the equation is that created that particular parabola? And the answer is yes, we can do it. This is the most simplest way to do it. This is when we know the vertex is at the origin. In a later video, we'll cover parabolas where the vertex is not at the origin. So how can I use a graph of a parabola with a vertex at the origin to find the function? And here are the steps to do this. The first thing you want to do is just start with function form. So let's write down what our function is going to look like in the end. So I'll change this to blue. Our function should look like f of x. We can just use the f value for the function. F of x is equal to ax squared. Remember, we've got no h and k and no other values. If we have a function that looks like this is our parent function if a is equal to 1. Remember our rules of a. If a gets bigger, it gets thinner. If a gets really, really small in the negatives, it gets upside down thinner. If a is between 0 and 1, it will get compressed or wider. So here's our basic function that we're going to start with. Now, step number 2 says replace x and f of x with the known point. Whenever you have a question like this, you'll always be given a point on the parabola. Now, we know that the vertex is at 0, 0, but you cannot use that point. It will not work. So this graph tells us that we also know that 2, 2 is on the parabola. So for this next step, let's just go ahead and write this down. Our known point is at 2, 2. And you know, class, that the first 2 is the x value of the point, and the second 2 is the y value of the point. So we're going to plug these into our equation. Well, the x value goes here. The y value is our output. 2 is our input. The next 2 is our output. So that means f of x gets replaced with the y value. So here's how you rewrite your equation. I'm going to change f of x to be the y value, which is 2. And then we don't know what a is. And our x value, we're going to plug that in parentheses. We know that's also 2. So we took this known point, 2, 2, took the x value, replaced the value of x in our function, took the y value, and replaced our output value, which is y, which is right here. Replace that with the y value. Now step 3 says evaluate x squared. Well, x squared is 2 squared. That means our equation is going to be 2 equals 2 squared is 4. I'm going to write this in proper math. I'll put the 4 in front. So 2 equals 4a. Step number 4, divide both sides by the coefficient of a. That means you want to get rid of the 4. We're trying to get a by itself. So step number 4, we're going to divide both sides. Oops, not by 2. We're going to divide both sides by 4. And that's going to leave us with the equation 2 over 4 equals a, which means that a, let's rewrite this, a is equal to, which means that a is equal to 2 over 4. We can reduce that to 1/2. So now we know what a is. A is 1/2, and we're done, class. Step number 5 is write the final function. We go back to step number 1, rewrite everything exactly the same, only now we have done our job. We figured out what the value of a was, which is 1/2. Now we can put the x back and put the f of x back. Here is our equation. If you made a table and you put a bunch of x values in and found all the outputs or the y values, this is exactly the graph that you would get if you graphed this particular function. Let's do a practice. If you would, class, pause the video. Try to do the next one on your own. It's important that you do that because this is a concept that many students will struggle with. Try to figure out the practice on your own. Once you've tried it in pencil, start the video back up again and follow along and see if you've made any mistakes. Okay, hopefully you've tried the practice now. Let's go through this same process. Step number 1, start with a function form. So we've got f of x is equal to a times x squared. There is our basic quadratic function. Step number 2, replace x and f of x with a known point. Well, our known point, looking at the graph, our known point is at -2, 8. We know the -2 is our x value and the 8 is our y value. So we're going to rewrite our function. Instead of f of x, we're going to replace it with our y value. That's 8. And then we still have an unknown a. Then our x value from our known point is -2, and that is squared. So again, look class, all we did was we took our known values. We know on this parabola, when you plugged in -2 in whatever function made this parabola, the output was 8. So we forced those two values into our function. The x value, there's our input, -2, and we know the output's going to be 8. Now we have to figure out what the value of a is. So question number, or step number 3 is, see if I get this right. Evaluate x squared. So x squared is -2 squared. That's going to be +4. So we're going to end up with 8 equals 4a. Remember, negative times a negative is a positive, so anything squared turns positive. Step number 4, we're going to get a by itself, so we have to divide both sides by 4. Write that correctly. Let's go ahead and finish that up. So that means that the 4's will cancel and we'll end up with 8/4 equals a. And that means a equals 8/4. We can reduce that, divide top and bottom by 4, and we end up with 2/1. So now a is 2/1. We could just rewrite that. Let's just rewrite this as 2/1, and we know that 2/1 is the same as 2. So our a value is equal to 2. Step number 5, write our function. Let's rewrite our function. F of x is equal to, well, now we know a is 2, x squared, and we just found the function that will produce this particular graph. So again, the trick here is to see that we're taking the value that we know on the graph, this 1 point, and we know the vertex is at 0, 0, and we're able now to figure out what was the function that actually created that particular parabola.